right, hello. Happy whatever day you're watching this. This lesson is a review lesson for our summative on systems. It's going to be it'll be on February 11th, or whenever you make it up if you happen to miss it on that day. So this is all about reviewing substitution, elimination, and then we'll spend a large chunk of time on some graphing. Alright, so basically how it's going to work is I'm going to model one for you of substitution, one for elimination, one of regular graphing, and then one with one in standard form. And then it is up to you to do the rest. You do have the answer key to check your answers. The sub and elim problems, you have the ordered pair, and the graphs I kind of explain why. If you want to do well and help yourself be better, make sure you don't just come here, look at the graphs, and then copy them. Okay? Try it first, and then look. That is how we learn. Okay. My copy. Alright, so let's go ahead and start with this first one on substitution. So we're going to plug one equation into the other. So I see x plus 3 here, and that is what y equals. So that is going to go in for y. So we're going to write x plus 3, and then that equals the 2x plus 4. So we just plugged it in where the y was, and then now we're going to go ahead and solve for x. So remember, with these problems, when we have it on both sides, we're going to move the smaller one over. So we have an x. I'm going to move that because it's smaller than 2x. Those cancel, and we get 3 equals 2 minus x is 1x. And then we subtract 4 on either side. And we get negative 1 equals x. From there, after we find x, we need to use that value and plug it back in to find our y. So what I'm going to do is I'm going to take this x here, and I'm going to plug it into that top equation for x, because now we know what x is, and x is negative 1. Color coordinate. And then we end up with y equals negative 1 plus 3, which is 2. And then we write it as an ordered pair. So negative 1, comma, 2. Remember, it's always x first and then your y value. So again, take x plus 3, plug it in for y, move your smaller x value to the other side, and then solve for x, plug that in to find your y. You need to do both of those. I need both x and y for these problems. This isn't a context problem where I'm asking you for specifically x or specifically y. To solve the system, we need the ordered pair. Alright, if you need more time with that, pause me and get it down. I'm going to move on to the elimination problem here. So we have negative 10x minus 9y equals 10. 8x plus 9y equals 10. Okay. Elimination, that means we are adding our two equations together, and we are going to look to see if any of these cancel. Remember, if they don't cancel, we have to multiply, but we have negative 10 and 8, and negative 9 and positive 9. Oh, there are my equal opposites. They're the same number, but opposite signs. Those are going to equal 0 and cancel out. Okay, so we eliminated those matching but opposite coefficients. Now we can go ahead and add these together. Negative 10 plus 8 is negative 2. 10 plus 10 is 20. This is negative 2 times x. We get rid of it by dividing. And we get x equals negative 10. Okay, so again, when we're solving this, we're adding our two equations together. I should see a big x, the things that are going to cancel, and then add what you have remaining. Negative 10 plus 8 is negative 2, 10 and 10 is 20, and divide. And then just like with our substitution problem, once we have our x value, we plug it back in to find our y. Same thing here. We have the value that we just found, and we're going to substitute or plug it back into one of our equations to find the other missing thing. Again, our problem isn't solved until we write this as an ordered pair, which means I need both x and y. So I'm going to rewrite one of those top equations. It doesn't matter which one. I'm going to choose the bottom one. It just has less negative signs, and that makes me feel a little bit better. I am not a fan of negatives. X is negative 10, so we're going to put that where x is. Eight times negative 10 is negative 80. Add 80 to both sides. And divide. And we get y equals 10. So, write it as an ordered pair. X is negative 10, y is positive 10. Alright, keep on going. Okay, I'll do one regular graphing and then one standard form graphing problem. Alright, so remember, if I ask you to solve by graphing, what I'm asking you to do is graph both lines and then tell me where they cross. So, we have this line right here, x minus 2. X minus 2 is my y-intercept, or minus 2 is my y-intercept, so that's where I'm going to start at. And then x is my slope. When I don't have a number in front of it, remember we imagined there's a 1 there? So that means I'm going to go up 1 over 1. Whenever we have a whole number in front of our x, we're just going up by that many over 1. If I gave you this equation, you're going up 7 over 1, up 3 over 1, up 4 over 1. So for this one, because there's a 1 there, we're going up 1 and then over 1. And we're going to graph as many points as possible because we do not know where our lines are going to cross. So we want to make a whole bunch of points so where they cross is clear. Okay, there's our first one. Now my second graph. Negative 5 is my y-intercept, so we're going to start at negative 5. And then negative 1/2 is my slope, so that means I'm going down 1. If it's negative, you're going down. And then to the right 2. Okay, well by going this way, we can see we're not going to cross with our graph. So we're going to have to go back the other direction. And we can see now that I'm making a point over a point that was already there. Ooh, my mouse is glitching. And if we zoom in, I'm going to draw my line. And my solution is right here where those lines crossed. So in this problem, it's negative 2, negative 4. Again, your x first, and then your y. This is your x right here. So x is negative 2, negative 4. Alright, last one I'm going to model for you. So same type of problem, we're graphing a system, so we're looking for where they cross. So let's go ahead and start. So we have plus 4 is our y-intercept. And then 1/2 means I'm going to go up and then to the right. So up 1, right 2, up 1, right 2, up 1, right 2. And again, we're going to make as many points as possible because we don't know where they're going to cross. To go backwards, you just follow the pattern. Okay, now let's do the other one. Uh-oh. So this one doesn't look like it normally does. This one's in standard form. Our x's and y's are on the same side. So we have to solve for y. I want y by itself. I have a negative x, so I just have to move that x over to the other side by adding it. And there is our new equation. 3 is our y-intercept. So we're going to make a point here at 3. Okay. And then right in front of here, there's nothing there. So that means my slope equals 1. So I'm going to go up 1 over 1. And we can see already where they cross. We have this spot right here, and that's the x value of 2, and then 5. So our solution for this one is 2, 5. All right, so a couple different types of problems. You have your example, an exemplar to look at. I want you to go ahead and try these 2 substitution, these 2 elimination, and then try all 4 of these graphing problems. And then again, you have the answer key to see if you got it right. Send me a message when you're finished so I know to check your work. Have a great day.